Hi, I'm Blair, Head of Engineering here at HeatMasterss. Today we're going to be diving into an interesting topic of air modulation. And it's going to be interesting, starting at ground zero, the basics of modulation, and working our way up to some of the more complex aspects of it, why it's beneficial to furnace owners, wood burning people alike, and how it's really opened up doors of opportunity for us to lower emissions, increase efficiency, make better use of the wood that we're putting into these furnaces. And we're excited to share that with you today. Well, today I want to chat a little bit more about fires and campfires and
energy.
Exactly, taking energy out of wood
To make heat.
You got it, exactly. And today I want to build on that a little bit more, but I want to talk about how we control how fast we get that energy out of the wood. Think about it like riding a bicycle. You ride a bike?
Yep.
You bet, right on. We think of our fire and controlling our fire a lot like riding a bike up a hill. You start riding a bike up a hill and you need to really push, right? You need to bike hard to get up that hill. So we turn on our air into our firebox and we want to make a big fire in there to make lots of heat. It's sort of like riding your bike up a hill. But when you get to the top of the hill, and if there's a long downhill stretch, you can get up a lot of speed, right? Going down that hill. Now, let's just say, for example, there was a stop sign halfway down the hill. How easy would it be for you to stop?
Not easy at all.
Not easy at all, no. What would you have to do to make sure that you could stop at that stop sign?
Crash into the side.
Crash into the sign, that would be one option, yeah. Look for something to slow you down. Yeah, and a fire is a lot like trying to go down that hill and stop halfway. A fire gets burning and it gets burning and bigger, but at some point we have to tell that fire to slow down and stop. But if we don't tell it to slow down, let's just say we close the door and we tell that fire, you have to stop right now. The fire doesn't want to stop. It's burning and that wood is hot and it's making lots of gas, all that energy that's coming out of the wood, and it doesn't want to slow down, it doesn't want to stop. But what if, when you were riding your bike down that hill, what if there was a long flat stretch at the bottom of the hill and then there was a stop sign?
That'd be a lot easier to stop.
A lot easier, right? And would you have to try very hard?
No.
No. How would you go about stopping for that one?
Just kind of stop a little from like the hill and then just keep stopping. You're still gonna drag a little.
Yeah.
And then you're gonna stop.
And it would be nice and smooth and no crashing into things, no locking up your brakes, right? It would be just coasting and then stopping. And that's how we like to control our fire. At HeatMasterss, we use 2 sets of dampers on our furnace, and that way we can help speed up the fire when we need it to make lots of heat. But once we have enough heat, we also need to slow it down. So we can close those dampers nice and slowly, and we can make that fire coast to a stop where it's nice and clean and a soft stop. Today I want to dive a little bit more into how we do that, how we control that process, and just maybe get some thoughts from you on how fire works, how momentum works alongside combustion. When you've got a unit, a furnace producing heat, that load on that furnace is not regular. It's not a flat line load. It's not consistent. For that reason, we've seen a deficiency in turning furnaces on and off. Your heat loads don't all just turn on wide open and turn off either. You may have small loads turning on like domestic hot water in a building. You may have large loads turning on like a big floor heat slab in a commercial environment. But our furnace needs to juggle all of those loads at the same time. We saw an advantage in being able to run our furnace at different output rates versus treating it like a light switch where we just turn it on and off. What kind of patterns would you see going in a combustion cycle if you've got a fire burning how would you want to treat that fire to be able to allow it to burn freely, but also within the boundaries you set on it?
Right, like you said, I guess you wouldn't want it to go on and off like a light switch, but maybe rather transition into it a little more smoothly, maybe like a dimmer switch.
Yeah, it's a great illustration. How do you see fire and momentum working together?
Well, typically you don't think of the two as being related, but I guess there is. Once you add more, say, oxygen, you're definitely putting more momentum into the fire.
Mm-hmm.
So in terms of that, I guess you could speed up a fire or speed up the process.
Right. Now, how would you see effectively dealing with that momentum on a downward cycle? If you need to slow this thing down, what would be a good strategy?
I'm killing the air cycle, reducing oxygen slowly.
Yeah, just letting it coast, letting it come to a
Gradual
rolling
stop.
stop
Yeah.
rather than locking up the brakes.
It's not a sudden thing, right? It has to happen gradually.
Right. Yeah, and we design all kinds of aspects of our furnaces based on this momentum principle. There's so much to be considered when dealing with fire and the momentum that it has. You want to make good choices when controlling a fire, and we do that based on how we supply oxygen to that upper firebox, which is initiating that gasification process. And that's why at HeatMasterss we use two fully modulating dampers to be able to control both our gasification process and our combustion side of the process. We almost treat them independent of each other because they're both very different scenarios, very different control strategies. And to be able to control that gasification process independent of that combustion side process gives us huge flexibility in how we start, stop, and modulate in between.
And that's something you wouldn't be able to do with just a single damper, right? Because you need to have control in both aspects
That's right.
of the burn process.
Yeah, to be able to control just the gasification side and not the actual combustion side would leave you in a very limiting position. To be able to do both of them independent of one another, it gives you a lot of advantages. Let's talk about some of the disadvantages in on-off. What are some cause and effect things that you would expect to see when you would hit a furnace like a light switch, on and off? What would you expect to see, say, at the start of a burn cycle and at the end of the burn cycle?
At the start of one, you'd probably see a lot of gases just being released into the atmosphere that could have potentially been used as fuel. And then maybe later on in the off cycle, you just kill it, and then it might take longer to heat back up again afterwards.
It involves heating that wood and heating it through. And in order to heat it through, you're building up a heat mass inside that piece of wood. And once that heat mass has reached its gasification point, now that wood starts releasing those tars and those smokes and those gases that we like to convert and use as energy in this furnace. To turn off that switch and to remove the heat from that piece of wood so that that gasification comes to a stop, that doesn't happen quick. That requires a bit of coasting time, a bit of slow down time to remove the oxygen from the process. And that oxygen is our generator. It's generating the heat that's driving that gasification process. What happens at the end of that cycle when you tell that fire you can't have any more oxygen? What do you see happening at the end of that cycle?
At the end of that cycle, I guess you would, if it keeps going, if the momentum's still there, but the oxygen isn't there, there wouldn't be a use for them. They would just go out your stack.
Exactly. Yeah, that smoke, the
Potential fuel is
gasification is
lost.
still happening. The heat is still there in large quantities, especially at the end of a longer burn cycle. And when that oxygen is cut off, your combustion will end, but the gasification process will not. So that gas is still being generated, and that's essentially why on a lot of furnaces that don't incorporate modulating dampers and that don't incorporate soft stops and softer starts, you'll end up seeing a lot of smoke coming off the stack at the end of a combustion cycle, at the end of a heating cycle, because that gasification process is still rolling, that momentum is still there, but you've taken away the oxygen to allow that gas to combust. The more we learn about fire and combustion, the more we realize that fire is it's a sensitive thing. It doesn't like quick changes, it doesn't like abrupt changes. And you can make a sudden quick change and the fire will protest by generating more smoke or less smoke, or more gases or less gases, which can really affect our combustion side of the unit. It's similar to the analogy we used with the kids about riding the bike down the hill. In this case, we want to give that fire less oxygen to slow the combustion down, but we want to do it in a way that respects the momentum. In a customer's perspective, you would see things like variable heating load. You're going to see your house or your shop call for heat at different times and for different lengths of time.
Right.
You're maybe going to jump in the shower and take a long shower, or maybe if you're in a hurry, you'll take a short shower.
Right.
And that's going to be a variable heating load on your furnace. And so our gasification it needs to be variable as well. That technology has come a long way in recent years. It's from, say, older models where we started working with gasification and doing it in a fairly fundamental process where we had a single damper and we were controlling all of our airflow using a single on-off type damper.
Yeah.
Well, later years we were able to modulate that damper and kind of ease our fire up and down
Right.
within that process. And recently now we've released models that have two dampers that are totally modulating independent of each other.
Is there a reason why 2 is better than 1? Are you able to control your temperature easier that way, or why exactly do you have 2?
That's a great question. We used to only have one damper on the furnaces,
Right.
but as we could see the deficiencies, the limitations in a single damper, we wanted to be able to add 2. And essentially what our first damper, we call it our top air damper,
Right.
is doing is it's controlling the gasification, the production of the gases
okay.
that we're burning.
Yeah.
So as we want more gases, more fuel for the fire, we're allowing more oxygen into that upper firebox, which is driving that gasification process. We're
okay.
producing fuel, essentially, producing
okay.
that gas.
Right.
The second damper is controlling combustion air, and that's what's burning off the gas. So we need to add just the right amount of oxygen to the combustion side of the picture.
Right.
And that's what's giving us the clean burn, and that's what's giving us the efficient burn. With a single damper, we ran into the challenges that at some points we were adding more secondary combustion air than what we actually needed.
Right.
And essentially what that does is it cools your fire off when you have more combustion air than necessary.
Right. Yeah.
And it's lowering your efficiency on the furnace. It's pushing in more cold air into this environment than what is
okay.
beneficial.
Right.
So by separating the dampers, we can also control the combustion of those gases.
Okay.
One of the ways we like to describe the purposes behind this dual modulation system is likening it to cruise control in a vehicle.
Okay.
If you had to drive down the highway in your truck and you had 2 throttle positions, on and off, what do you think? How do you think that would impact your fuel economy?
No, it wouldn't be so good.
Not
Somewhere in between would be good.
somewhere in between, yeah. And if you had the option of being able to have variable positions, but when you're encountering things like hills and valleys, we like to liken modulating dampers to cruise control to be able to help our customers understand the benefits of backing off on the throttle when the heating load is lessening and applying the throttle again when we need that extra horsepower to generate the heat that we need
Yeah, makes
for
sense.
supplying heat to the customers' buildings. What about flexibility to be able to burn different types of wood, different types in different conditions? Would you see 2 tuning and customization being important to you versus maybe a customer at a different altitude and burning different types of wood in a different location?
Oh, having that flexibility would be great. Like we have access to all sorts of different kind of wood, but be able to burn whatever, that you don't have to go out and drive whatever a couple of hours to be able to source a certain kind of fuel would be huge.
How would you see the modulating damper system affecting you as a consumer?
Well, to me, I'm thinking that if I can get wood from a variety of places at a variety of different moisture levels, and be able to use it at different altitudes, or at my particular altitude, and not have to worry about it, to me that would be a huge benefit. And to be able to use the emissions as well, that only to me tells me that I have to go out there and load the unit less often, and it's just going to be more efficient. So to me, that it's a no-brainer. If it's going to put more BTUs out there, let me get more warmth and not have to work as hard, I'm all over that.
For sure. That's just part of the process. That's a huge driving factor.
Yep.
We don't want to waste anything. We know how much energy goes into growing the wood, processing the wood, drying the wood, loading the furnace. It's a discipline that people are putting effort into doing.
Yep.
And we want to try to respect that and use it to the fullest extent. And I know that there's always room for improvement. We're excited about where we're going with this combustion, with the combustion control that we've been able to get using this dual modulation system, and how it benefits the consumers. What drove us to the dual damper system? What were the drawbacks that we were fighting with our single damper, our single top air, bottom air control?
So through the burn of a cycle, having loaded the firebox with fresh wood, till the end of the burn cycle, when the firebox is empty, there is differences in the requirements for oxygen, and we need to be able to control independently top air versus secondary air to achieve the clean combustion that we're looking for.
The challenges between controlling gasification at one end of the spectrum and combustion at the other end of the spectrum, it's almost two separate processes happening within that furnace at the same time. We could see it and we could feel it through the development phases, that we were always lacking that flexibility. We needed to be able to roll with the punches better in our firebox and in our gasification control, and it seemed like we were suffering because we didn't have that second modulating damper. We needed more air in the bottom, but we couldn't give it more air because the top was already at maximum. Or we needed to be able to limit the top, but we still needed that oxygen in the combustion side of the picture. And we could never find that best of both worlds, or at least not consistently throughout that combustion cycle, from a fresh load of wood to the time to reload. The conditions, the gasification was always changing. When the firewood would shift and settle within the firebox, we didn't see that continuity all the way through the cycle.
That's right. And there's additional variables, different species of wood, different qualities of wood, different moisture content of wood. They all have their variables, and the furnace will tune itself based on those variables. Another variable is altitude. We have customers burning boilers up high altitudes, less oxygen up there, and the boiler is set up in a way where you can dial in the oxygen level that you need.
That's a huge benefit to the customers, is to be able to tune that furnace to their own conditions and their own wood type. I mean, right. You have a customer burning hardwood in a lower altitude versus another customer in another application burning softwood at a high altitude. The oxygen requirements are different. The oxygen content of the air is different. And we have the flexibility now to be able to adjust our minimum and maximum damper positions. We can adjust the throttling ranges between those top and bottom limitations and create similar output on the furnace in those different conditions.
It's exciting seeing what we're going to be able to do moving forward.